In this video, we'll be talking about the Wilcoxon signed rank test. It is a non-parametric equivalent of paired samples t-test. So once again, if we're unable to meet the assumptions of paired samples t-test, we choose its non-parametric equivalent. So let's take a look at this example. So assuming that you have 15 students who took their pre-test and post-tests and got the following scores. So one of the common assumptions for a parametric test is the test of, or the assumption of normality. So we'll be checking if this, or the pre-test scores and the post-test scores are normally distributed. So once again, to check for the normality, you go to Analyze, Descriptive Statistics, Explore, and then we move the pre-tests and post-tests to our dependent list. We click on Plots and choose Normality Plots with Test. We click on Continue and then click on OK. So once again, we are after the Shapiro-Wilk value here. So this is the Shapiro-Wilk value, particularly the sig value. Once again, to pass the test of normality, the sig value for both the pre-test and post-test here should be greater than 0.05. Since the computed values or the computed sig values here are both less than 0.05, meaning to say that we failed the test of normality. Therefore, it's not appropriate to use paired samples t-test, in which case we choose Wilcoxon signed rank test. So how do we run the Wilcoxon signed rank test? To run the Wilcoxon signed rank test, all you have to do is to go to Analyze, Non-Parametric Test, Legacy dialog box, and we choose two related samples. So similar to paired t-test, you could actually click on pre-test here and click arrow to move it to the right pane, and click post-test and click arrow to the right to move it to variable 2. Or let's move this 2 back. You may simply just do drag and drop. Drag pre-test to variable 1 and post-test to variable 2. If you noticed, Wilcoxon is already checked by default. So you just have to click on OK, and there you have it, the value for the Wilcoxon signed rank test. So you will be getting the z value here and the sig value, which is also known as the p value. So if we are to report that in our table, so let's have here an example of our table. So we have variables, so we have pre-test versus post-test. And then we have here the z value, so that's the Wilcoxon signed rank test value. We have the p value, we have our interpretation, and our decision. So we'll just be getting the computed values here. So that's negative 1.39 and 0.163. So negative 1.69, 1.39 rather, and 0.16. Once again, since the p-value is greater than 0.05, interpretation will be not significant. Since the interpretation is not significant, our decision will therefore be accept the null hypothesis, which means that there is no significant difference between the pre-test and post-test scores of the students. Again, if the p-value is greater than 0.05, interpretation is not significant, we accept the null hypothesis. If the p-value is less than 0.05, interpretation will become significant and the decision will become reject HO or reject null hypothesis. So that's basically it for Wilcoxon signed rank test using SPSS.